What if I told you that the intense, borderline obsessive scrubbing and sanitizing we all did during the COVID-19 pandemic might have actually accidentally accelerated an even deadlier global threat?
Yeah, it's one of the most sobering ironies of modern public health, honestly.
Right, because today we are looking at the ultimate evolutionary arms race and, well, how our best intentions might actually be arming the other side.
We really thought we were building an impenetrable shield, but on a microscopic level, we were basically building a training ground.
Okay, let's unpack this.
Oh.
Welcome to today's deep dive. I'm your host, and I've got our resident expert here to help decode all of this.
Glad to be here. We have a lot of ground to cover today.
We really do. We've got a massive, genuinely fascinating stack of sources in front of us. We're pulling from World Health Organization guidelines, heavy-hitting medical journals like The Lancet, some brilliant science essays from Astromirth, and this part is wild, the visionary blueprints of a medical pioneer named Dr. Srivatsa.
It's a really diverse set of materials.
It is. And our mission for you today is to decode what experts are calling the silent pandemic.
Wow.
We are going to figure out how human behavior, from our agriculture to our wastewater, is supercharging this threat.
And crucially, how a truly unexpected blend of artificial intelligence and ancient philosophy might actually be our best way out.
Yeah, because we need a way out, right? Urgently.
Oh, incredibly urgently. The projections in these sources are just grim. If we leave this unaddressed, antimicrobial resistance, or AMR, is projected to claim up to 10 million lives a year by 2050.
10 million a year.
A year. To put that in perspective for you, that could surpass other major causes of global mortality and the economic toll. The World Bank estimates it could cost the global economy trillions of dollars.
Trillions, wow.
Yeah. We are looking at a scenario where routine surgeries, cancer chemotherapy, or even just treating a simple scratch from your garden could become life-threatening.
Just because the antibiotics we rely on just won't work anymore.
Exactly. The drugs simply won't work.
It is a terrifying paradigm shift, really, when you realize that antimicrobials are basically the foundational cornerstone of all modern medicine. So, to understand how to stop this threat, we first have to understand the mechanics of the enemy.
Right.
How does a normal, run-of-the-mill bacteria turn into an untreatable superbug?
Well, it fundamentally comes down to selective pressure.
Okay, selective pressure. Break that down for us.
So when you take an antibiotic, you are introducing a targeted chemical weapon into your body, right? It's designed to kill the bacteria causing your infection.
And it usually works, mostly.
It does. It wipes out the susceptible bacteria. But, in any given population of billions of bacteria, there are always naturally occurring genetic mutations.
Like just random flukes in their DNA.
Precisely. Some of those random mutants happen to possess traits that protect them from that specific drug. So the drug clears out all the weak ones, leaving behind only the strong, resistant mutants.
Oh, man. So those survivors then multiply.
They do. They multiply, creating a whole new strain that is completely immune to the weapon you just used.
It makes you think about, well, every time you or I have felt better after 3 days of a Z-Pack and tossed the rest of the pills in the bathroom cabinet.
That is the classic mistake.
Right. We think we're being safe by taking less medicine, but biologically, we're just running a boot camp for superbugs inside our own bodies.
That is the perfect way to visualize it.
We kill the easy targets and leave the elite squads behind to multiply.
You are artificially applying selective pressure and actively aiding their evolution.
And reading through the sources, the physical ways these bacteria actually defend themselves are wild. It's like, I don't know, it's like they're video game characters finding cheat codes.
Mechanisms are incredible, yeah.
For one, bacteria can literally change their physical permeability. They have these microscopic channels in their cell walls called porins.
Yes, porins.
The source actually compared them to the little green pipes in a Mario game. The bacteria can just mutate to manufacture fewer of these pipes or change their structural shape entirely.
Effectively locking the drug out.
Exactly, which is an incredible physical defense.
But the active defenses are even more aggressive, honestly.
Right. The efflux pumps, I was reading about those.
Yeah, if an antibiotic does manage to slip past the outer wall and get inside, the bacteria utilizes these little molecular pumps to literally spit the drug right back out into the environment.
Before it can even bind to anything and do damage.
Exactly. But what's fascinating here is that they don't just keep these survival cheat codes to themselves.
Wait, what do you mean? They share them?
Oh, yeah. Bacteria utilize an incredibly efficient mechanism called horizontal gene transfer. They carry resistance genes on these tiny mobile loops of DNA called plasmids.
Okay, plasmids.
Think of a plasmid like a microscopic USB drive. A resistant bacterium can pull up next to a completely non-resistant bacterium and just copy and paste that plasmid right over to them.
I found this part so alarming in the text. So they don't even need to reproduce to pass on this resistance.
Nope.
They just bump into a neighbor and airdrop the files.
That's exactly it. And the scariest part, they can do this with entirely different species of bacteria.
Seriously? Different species?
Yeah, it completely flips our traditional understanding of evolution
Yeah.
because it is essentially cross-species data sharing.
Oh, wow.
A harmless bacteria living in your gut could receive a plasmid from a dangerous pathogen, or vice versa.
Meaning resistance can spread through an environment at a speed that is completely independent of normal biological reproduction.
Which brings us to a massive blind spot in this whole crisis.
Right, because the human body is just one tiny theater in this war. If bacteria are constantly adapting, why are they suddenly adapting so incredibly fast globally?
We have to zoom out to the macro level.
Yeah, the environment, our massive industries,
Yeah.
we start to see the unintended accelerants.
And the scale of those accelerants is staggering. Let's look at global agriculture, for example.
Oh, the agriculture stats were mind-blowing.
According to the Lancet source we reviewed, in 2017, a jaw-dropping 73% of all antimicrobials used globally were used in animals.
73%. I mean, we always think of antibiotics as human medicine, right? Like a
Mhm.
doctor writing a prescription.
Most people do, yeah.
But the vast, overwhelming majority of it is actually being poured directly into our food supply.
And historically, it hasn't just been used to treat sick animals. That's the issue.
Right, they use it preventatively.
Exactly. These drugs have been used extensively for disease prevention in highly crowded agricultural settings and even systematically fed to livestock to promote faster physical growth.
Which just creates massive, unseen reservoirs of antimicrobial resistance genes out in the world.
Huge reservoirs. And those genes can then be transmitted back to humans directly through occupational contact or through the food chain itself.
Or indirectly, right, when agricultural runoff contaminates the local water and soil.
Yes, allowing that horizontal gene transfer to happen out in the open environment.
But the tide is slowly turning there, thankfully, largely because of consumer awareness. The sources highlight a massive turning point in 2014 with the fast food chain Chick-fil-A.
That was a significant industry shift.
Huge. They made a public pledge that by 2019 they would only serve chicken raised entirely without antibiotics.
And when a corporate buyer, that massive changes its standards, it forces the entire agricultural supply chain to adapt almost instantly.
Right. It shifts AMR from being purely a clinical issue into a fundamental supply and demand issue.
It is a perfect real-world example of how interconnected human, animal, and environmental health truly are. It's what public health experts call the One Health approach.
We cannot solve the human side without addressing the environmental side.
Exactly.
And speaking of the environmental side, this leads me back to the hook we started with, which I think is a brilliantly counterintuitive question.
The COVID sanitization paradox.
Yes. During the COVID-19 pandemic, the entire globe became like hyper-focused on hygiene. We were scrubbing down our groceries, bathing our hands in sanitizer.
Fogging every public surface with industrial disinfectants.
Right. I read the ecotoxicology report in our stack, and I was genuinely shocked. We were flushing thousands of tons of heavy-duty chemicals down our drains.
Specifically quaternary ammonium compounds, or QACs, and benzalkonium chloride, BAC.
Yeah. But my question is, since those are heavy-duty disinfectants, shouldn't they just be obliterating whatever bacteria are in the wastewater? Didn't that make us safer?
It's a very logical question, but the environmental data provides a very sobering answer.
Which is no.
No, it did not make us safer in the long run. When we flushed thousands of tons of these biocides into our wastewater systems, they eventually reached our rivers, lakes, and oceans.
Right.
But they don't just disappear. They dilute into what scientists call a sub-minimum inhibitory concentration, or sub-MIC.
Okay, sub-MIC. So is it essentially like giving a vaccine to the bacteria in our rivers?
Kinda, yeah.
Like we're dosing them with just enough of the poison to trigger their stress responses and build an immunity, but not enough to actually wipe them out.
That is an excellent analogy. The concentration is high enough to stress the organism, which accelerates mutation, but low enough that they survive.
Wow.
It is the exact recipe for selective pressure, just happening on a planetary scale. We essentially enriched antibiotic resistance out in the wild.
And the collateral damage was severe, right? The source specifically mentioned the impact on aquatic life.
Correct. Studies on rainbow trout showed that chronic exposure to even low concentrations of BAC caused significant genetic damage.
To the fish themselves.
Yes. It altered their critical enzyme activity, damaged their gills, which, are their primary organ for respiration and filtering out toxins, and measurably increased their genetic damage index.
That's horrifying.
Hmm.
We tried to aggressively sanitize our way out of a viral pandemic, and in the process, we polluted our global waterways with mutagenic chemicals.
Chemicals that are now accelerating bacterial resistance.
So we are inadvertently training natural Earth bacteria to fight our best weapons. But our sources take us to an even darker thought experiment.
Oh, this part is fascinating.
What if the organism we're facing doesn't play by the rules of natural Earth evolution at all?
You're referring to the mirror life concept discussed in the Astromirth materials.
I am, and it is fascinatingly terrifying. To understand it, we have to talk about chirality, which is basically the handedness of molecules.
Right, the geometric orientation.
Essentially, all life on Earth relies on molecules that are structurally shaped in a specific direction. It's like how your right hand is a mirror image of your left hand, but you can't perfectly stack them on top of each other.
You don't overlap perfectly.
Right. Life on Earth uses left-handed amino acids and right-handed sugars to build its proteins and DNA.
It's the fundamental structural geometry of biology. Every enzyme, every natural predator, every immune cell on Earth is deeply calibrated to interact with that specific, naturally occurring molecular geometry.
So imagine a synthetic bacterium created in a laboratory where that entire geometry is flipped.
It's a perfect mirror image.
Yeah. Astromirth uses this brilliant analogy to explain the danger. Imagine natural evolution is a foot race that's been going on for millennia.
Okay.
All the native runners know the terrain, they know each other's speeds, they know the rules. Then suddenly, you drop in a brand new racer wearing roller skates.
The native runners wouldn't even know how to begin competing with that. They can't just suddenly evolve roller skates mid-race to catch up.
Exactly. Which means if a mirror bacterium escaped into the wild, it would trigger an ecological catastrophe. Why? Because our world literally wouldn't recognize it.
The ecological implications are profound to think about. A mirror bacterium in the wild would have absolutely zero natural predators.
Yeah.
No existing earth virus could infect its cells. No native soil organism could consume or break it down.
Because they can't physically bind to it?
Exactly. Even if it grew slowly at first, its uninhibited growth would be relentless. It would start consuming the universally available non-chiral resources.
Like what?
Things like sunlight, water, and basic inorganic ions.
And because nothing is keeping its population in check, it would eventually just outcompete native life for those basic building blocks.
Leading to a total collapse of biodiversity. And
Wow.
from a human health perspective, our immune systems wouldn't even be able to see it to fight it off.
Because our antibodies are physically shaped to bind with normal Earth geometry proteins.
Right. It highlights the absolute extreme end of what happens when biological balance is fundamentally disrupted.
Which is a terrifying endpoint. Whether we are dealing with a mutant superbug trained by our own wastewater or some synthetic nightmare organism on roller skates, the core problem is speed and invisibility.
They move incredibly fast.
These threats move through our environments, our water systems, and our infrastructure entirely unseen. So how do authorities actually catch an outbreak before it becomes a global headline?
It's a massive challenge.
We clearly can't just wait for thousands of people to show up in the emergency room.
No, absolutely not. Public health officials have to operate like high-stakes detectives. The WHO outlines a very rigorous 10-step approach for outbreak investigation.
And the most critical element of this methodology is that it's dynamic.
Highly dynamic. It happens in real time, often with terrifyingly incomplete information.
The sources gave a really vivid case study of this from 2019 in Aski, Norway. And reading through it, I mean, it really does read like a thriller.
It really does.
Aski is an island municipality with about 29,500 inhabitants. On June 6th, seemingly out of nowhere, 10 people were hospitalized within 24 hours with severe gastrointestinal issues.
And 30 more called into primary care.
Right.
That is step one, detecting an unexpected increase in cases in a specific time and place. But the medical officer doesn't just look at the clinical symptoms, they look at the map.
Geography is key.
They immediately noticed a tight geographic clustering. The patients all live near each other. But at that exact moment, they only had one single positive lab test for Campylobacter.
Just one test.
That's all they had to go on, one test.
And the tension here is wild. They have exactly one test, but there's a whole town still drinking the water.
Yeah. That is the crucible of public health. You are staring at incomplete data while the clock is ticking. Through rapid interviews, they traced the geography back to water supply system A, which served about 12,000 people.
Which leads them to discover that a specific part of the system reservoir X was essentially an unlined mountain cavern.
Yes.
But here's the part of the methodology that stood out to me the most. If they wait for the lab to culture the water samples and give them 100% definitive proof, hundreds, maybe thousands more people get infected.
And that introduces the most vital rule of any outbreak investigation, the precautionary principle.
Do not wait.
Exactly. Do not wait for lab results to implement control measures.
They acted on the epidemiological pattern before the microscopic proof even arrived. They issued a boil water advisory instantly on June 6th.
And by June 7th, they took Reservoir X completely offline.
The investigation continues after that, of course. They take environmental samples, they interview cases, they define the exact parameters of the outbreak.
But stopping the immediate harm based on the available patterns is always the absolute priority.
So that is how we act when the dam is already broken. We track the geography, we isolate the source. But if we want to stop the root cause of antimicrobial resistance, we have to look way upstream.
Way upstream.
We have to look at the everyday, ground-level interactions between doctors and patients. The everyday misuse of antibiotics driven by pure human fear.
That requires a completely different kind of intervention. It requires addressing the psychology of the human element.
And this is where we bring in the work of Dr. Srivatsa. The sources make a fascinating comparison between Dr. Srivatsa and Charaka, the ancient pioneer of Ayurvedic medicine from the 1st century.
It's a beautiful parallel.
Charaka used ancient philosophy, observing the elements around him to create preventative daily rituals, keeping the human body in balance with nature.
And Dr. Srivatsa is applying that exact same ethos of preventative, patient-centered care, but he is using the most advanced technology we have available today.
Artificial intelligence.
Right. He developed the Prima kiosk and the Dr. Maya GPT system.
The logistics of his plan are incredibly ambitious.
Yeah.
He's not targeting fancy hospitals in major metropolitan cities. He is purposefully targeting the most vulnerable populations.
Specifically, illiterate women in rural India, street vendors, domestic laborers.
The plan aims to deploy 100,000 of these AI diagnostic kiosks nationwide by 2030.
The goal is preventative interception. The kiosks serve to diagnose minor infections early and guide patients with accurate medical knowledge.
Instead of them just guessing.
Exactly. The projection suggests that this could prevent 10 million unnecessary antibiotic courses and save 50,000 lives from AMR complications.
That's massive.
By catching illnesses early at the street level, they can isolate the infected and stop the transmission chain before it ever reaches a crowded hospital waiting room.
So what does this all mean on a deeper philosophical level? Because the choice to name the AI Maya isn't random.
No, it's very intentional.
The text connected to the ancient Hindu concept of cosmic illusion. There's this incredible audio transcript in our sources that uses a brilliant analogy from the ancient sage Shankara.
A snake in the rope.
Yes. Imagine you are walking into a dimly lit room. You look down and see a coiled shape on the floor. Instantly, your brain screams, "Snake!" Your heart pounds, your adrenaline spikes, you start sweating.
And the physical reaction, the pounding heart, the sweating, that is entirely real to the person experiencing it. The terror is genuine.
Completely genuine.
But the object on the floor is just a piece of rope.
It's just a rope. But your brain projected the fear. When a patient gets a runny nose or scratchy throat from a basic, harmless viral cold, that viral cold is the rope.
But their uninformed brain screams, "Snake!"
It screams, "Chest infection, I am in danger, I need antibiotics right now." That illusion of fear is what drives the global misuse of medicine.
If we connect this to the bigger picture, Dr. Maya GPT acts as the light switch in that dimly lit room.
I love that.
It forces a pause between the fearful stimulus and the medical reaction. An illiterate patient can step up to the kiosk, speak to the AI in their own local dialect, and describe their symptoms.
And the AI systematically analyzes the data.
Right, and gently explains that they are looking at a rope, not a snake. It replaces a fear-driven system where a panicked patient demands antibiotics from an overworked, exhausted doctor with a trust-driven system based on accessible knowledge.
And the text actually frames this through the concept of Dharma restoring the cosmic order or moral balance. By giving these women the diagnostic tools to understand their own bodies, Dr. Srivatsa isn't just handing out medical charity, he's empowering them.
It's technology giving them the knowledge to take responsibility for their own health, which restores balance to the entire medical ecosystem.
It is a profound shift from reactive, panic-based medicine to proactive, knowledge-based empowerment.
It truly is.
Which really brings this whole conversation full circle, right back to you listening. The fight against antimicrobial resistance isn't just happening in WHO laboratories in Geneva or deep inside unlined mountain reservoirs in Norway or even at AI kiosks in rural India.
It is happening in your own home.
It happens every single time we decide to actually finish a full prescription or when we accept that a viral chest cold doesn't need a bacterial nuke to cure it. We have to trust the light switch over our own fear of the snake.
I want to leave you with one final thought to mull over.
Okay, let's hear it.
We spent the beginning of this deep dive talking about how microscopic bacteria manage to survive against incredible odds because they cooperate.
Right.
They seamlessly share their genetic cheat codes, their plasmids, with entirely different species across the globe via horizontal gene transfer. They adapt as a massive, borderless collective.
Yeah, they don't care about national borders or species lines. They just share the data to survive.
To add to that, shouldn't humanity's survival strategy mirror that exact behavior?
Oh, wow.
If we don't start sharing our epidemiological data, our diagnostic innovations like Dr. Maya, and our resources across all national and economic borders, a true One Health horizontal transfer of human knowledge, we might just lose the evolutionary race to organisms that figured out how to cooperate millions of years before we did.
Wow. We started by talking about how our obsessive sanitizing trained our invisible enemies to be stronger. Maybe the only way to beat them isn't by building a better chemical weapon, but by building a better system of cooperation.
That's the real challenge ahead of us.
That's all for today's deep dive. Stay curious.